Assalamu alaikum wa rahmatullahi wa barakatuh. Hello my little scientists, how are you today? Wish you are fine. I'm Mrs. Sameh Hassan from Taqwa. Let's start our session today. It will talk about oscillatory motion. We all know that the meaning of motion, and we have two types of motion. The first one is transitional motion. Second one is periodic motion. So what's mean by periodic motion? It is the motion which is regularly repeated at equal periods of time. And transitional motion, motion from starting point to ending point. The periodic motion has two types. The first one is oscillatory motion. The second one is wave motion. We will talk about the relation between velocity of an oscillating body and its kinetic energy. The kinetic energy equals half time mass time v square. So the kinetic energy is directly proportional to the mass of oscillating body and the square velocity of an oscillating body. So kinetic energy equal what? Great. Half time mass time velocity square. So kinetic energy directly proportional to, yes, mass and square velocity of an oscillating body. Look at this spring. The motion of the spring is regularly repeated in equal periods of time at two sides of its rest position. This is the rest position, and it moves up and down. So what happened to the velocity of an oscillating body? Yeah, of course, the velocity of an oscillating body is very high when it passes the rest point or rest position. And what happened when it moves away from the rest point? Yes, of course, the velocity decreases until it reaches zero at maximum displacement. Look at this pendulum. This represents the rest point. So this pendulum moves at right. So the speed here decreases gradually until it reaches to zero. And when it passes the rest point again, the velocity increases. And also when it moves left, the velocity decreases. And it increases again when it passes the rest point. We conclude that the motion of weight, which is called the simple harmonic motion, is considered the simple form of oscillatory motion. So, what about the simple form of oscillatory motion? Great, it is the harmonic motion. Okay, look here, the rest point, motion of a spring upward and motion of the spring downward. So, like we said, the velocity increases as it passes the rest point. Look here, in the simple harmonic motion, the velocity of an oscillating body is inversely proportional to the displacement away from the rest position. As it moves away, the velocity decreases. And as it approaches the rest point, the velocity increases. Let's see this exercise. The oscillating body moves at the two sides of its rest position, so its velocity, yes, can you guess? Amazing. decreases when it goes far from its rest position. So, today we talked about the relation between the kinetic energy and velocity of an oscillating body. Like we said, kinetic energy equal half time mass times v square. So, kinetic energy is directly proportional to mass and square velocity. We all know that as the oscillating body passes through the rest point, its velocity increases. And as it moves away from the rest point, its velocity decreases. Hope you enjoyed our session today. Thank you. Goodbye.